Hi everybody, hope you can hear me okay. Thank you very much for tuning in today in the latest of our Bogtastic webcast series from Moors for the Future Partnership. Hopefully at some point very soon there'll be a link dropped into the Bogtastic webpage to watch any previous webcasts if you've missed them. This is the third in the series, and they are in lieu of the fact that we can't take our Bogtastic van out at the moment and do our usual programme of engagement events. So these webcasts are part of our More Life 2020 project, which is funded by the EU Life programme, Yorkshire Water, United Utilities and Severn Trent. So my name's Charlie, I'm from the communications team at Moors for the Future Partnership, and today I'm joined by Tom Spencer, a research monitoring officer in the science team at Moors for the Future. We'll be talking about his science work on Kinder, probably for about 30 minutes, and we'll have a Q&A session at the end. So please do post your questions in the chat bar if you're watching live, and we'll try to answer as many as possible at the end. There'll also be some handouts appearing as we go along. These will open in a separate tab, but do have a look at those if you would like to find out a bit more information. And we'll also have a few polls and a few quizzes as well to do, so we hope you enjoy it. So I'll be asking Tom about his work on Kinder Scout. And to begin with, just to give us a bit of background, Tom, please can you fill us in on the history of the site?
Yeah, sure. So the project that I work on is based on, as you said, on Kinder Scout. And you can see an aerial photo on your screen at the moment, which was taken in 2013. The restoration work that we did started in 2011. And at that point, the whole of the plateau, or a large amount of the plateau, was just bare peat. So all the vegetation had been lost, largely through the Industrial Revolution and atmospheric pollution. And so we sort of did our standard set of restoration interactions on bare peat, which was covered a bit by Katie Thorpe in her webcast last week, if anyone saw that. But essentially, we put down chopped up heather brash on the bare peat surface. That helps to stabilise the surface. And into that, we put a mixture of lime and seed and fertiliser. And the seed is what we call nurse crop grasses. So they're the kinds of grasses you might get on a football pitch or on a lawn. They're quick to grow, and they stabilise the whole surface, lock it all together, and allow the more natural species to come in. We also put, with the National Trust, a whole stock exclusion fence around the entire plateau to keep sheep off, to protect the young plants as they were starting to grow. We also did some gully blocking. So where we've got deep gullies from erosion, we've blocked them with stone and timber. And we'll talk about that a bit more later on. And we've also planted a whole load of sphagnum moss up there. And so in this photo, you can see that the young plants are just starting to grow. And so it's not as brown as it was. And you can just about make out a brown square in the sort of right middle side of the screen. And if we go on to the next photo, you can see that brown square is still there, but the plateau as a whole has greened up a whole load more. So that's over 5 years. So the vegetation is really thickening out and getting a lot better. And the work that I'm involved in is as you said, is the science work that we do at Moors for the Future. So what we're looking at is trying to evidence the impacts of the restoration work out what happens when we do our restoration work. So on Kinder Scout, in collaboration with the University of Manchester, who we work very closely with, we set up an experiment to directly compare what happens in that square that we left as the bare peat control site, where we did no work at all, no restoration work at all. That's exactly how it was, with two other mini catchments a bit further to the west across the plateau, where on one site we did our standard revegetation work, and on the other one we did the revegetation work and also the gully blocking, and then also planted a lot of sphagnum. So we can compare the impacts of those different restoration interventions directly with each other. So yeah, that's a sort of very brief overview of the project. Yeah.
Okay, So how often do you go up on Kinder, and what do you do when you're there? Can you tell us?
Yeah, so my fieldwork on Kinder revolves around two main kinds of things. The first is working with volunteers, which is what we've got here. The left-hand picture is part of the hike up onto the plateau, which takes a bit over an hour, and it's fairly steep, as you can see from that. And so with those volunteers, what we were doing on that occasion, which was in 2018, was we were planting sphagnum moss, which is the little green plants that you can see on the right-hand side. So we're planting them into the streams in particular to see what impact sphagnum has on storm events when the water's flowing through the streams really quickly. So we also, with the volunteers, we do our vegetation surveys in the summer and our water table surveys in the autumn. So that's, again, looking at the impacts of restoration on the types of vegetation that we have growing up there and what happens with water table following restoration. The other fieldwork that I do is going up every fortnight, not at the moment, obviously, but in normal conditions. So I go up every fortnight, and if we skip on to the next picture, you can see the kind of things that I'm doing up there. So this is one of the mini catchments that I was talking about, where we're measuring how much water is flowing out of the streams all of the time. Every 10 minutes, we're taking a measurement of how much water is flowing out of each catchment. So that means I have to download the data from those loggers. There's one in that white tube that you can see just to my right in that picture, over my right shoulder. And so that the equipment takes a bit of maintenance and a bit of downloading. I'm also taking water samples so we can look at water quality and what happens to water quality when we do the restoration work. So yeah, there's some amount of maintenance to do and downloading from the loggers and that kind of thing. Just keeping an eye on the sites, making sure everything's ticking over.
Do you always enjoy your field work?
In a word, yes. I guess, yeah, you can see from that the weather sometimes presents interesting challenges. I absolutely love days like this, but for the work itself, it's quite challenging if you can't find any of the equipment because it's buried under several feet of snow. But yeah, I mean, it's definitely true to say that I've got rained on in my field work before, but I love every minute of it. Every minute of it is great. Yeah, I mean, the Kinder Plateau is without doubt my favorite place in the world. It's amazing. I mean, yeah, I guess because I've been there a lot, you get to know it in a really particular way, so you feel like you're starting to recognize the short-eared owl and the different mountain hares there are up there and that kind of thing. Yeah, no, it's fantastic. I love it.
Yeah. Well, I've been out with you once before planting sphagnum, and it was a really good day, even though it was freezing, but it was a lovely environment. So can you tell us a bit about what does a functioning bog look like?
Yeah, so this is a picture from the Kinder Plateau, and this is a really successful little patch where we've got basically a nice mixture of different plants growing. So we've got some shrubs like the heather, and we've got grasses which are coming up through that. And then underneath, we've got a really nice dense layer of sphagnum moss, which is that kind of red and green kind of moss that you can see underneath there. So essentially a nice mixture of different plants and a very high water table. So the ground is really wet, which allows those species to grow. And the sphagnum in particular, we're very interested in. It's one of the key species in a blanket bog. And it's one of the key species which helps to actually build the peat itself historically, and we hope it, now and in the future.
So what did it look like at the start of the project?
Not like that, more like this. Yeah, so a lot of bare peat all over the place, with isolated bits of vegetation in between, the really gnarly stuff that can cling on in essentially a desert. So highly acidic. It's very exposed, so it's going to be hard for anything to grow, which is why we need to put that brash down to start with to stabilize the surface. So yeah, to be clear, our starting point was very bad. Like it's, the South Pennines are among the most degraded blanket bogs in the world. It's a really severe situation that we started from. So in terms of our aspirations for restoration, we can set things off in a positive direction, and some of the achievements that we've made through those interventions have been quite remarkable. but we've got a very long way to go to get it looking like a really healthy bog. What we found is that we can get that mixture of species, the vegetation species, to grow. They will grow and they will thrive, but in terms of the full functioning of the bog, it has got a very long way to go. It's a long-term project.
So you do think it is possible that Kinder could look like the good picture of a bog?
I mean,
once again?
yeah, I mean that picture was from the Kinder Plateau. So in areas, certainly it can look great already, and will look even better in the future. So bits of it are possible for sure, but that's why we do the monitoring, is to see what's possible and to push our understanding of what is possible.
So I believe you're going to tell us about 3 aspects of the experiment on Kinder, and the first aspect is erosion. So can you tell us what erosion is, and also introduce your first quiz?
All right, yeah. So erosion is in this context is where we have the soil being very exposed because there's no vegetation to hold it together. So it's exposed to wind, exposed to rain, it's exposed to high temperatures, to low temperatures through freezing. All of those things will break up the peat on the surface, and then when it rains, it will wash down into the streams and be lost from the moors. So we've lost several meters vertically of peat from the Kinder Plateau in areas. So that's what the erosion is. That's why we have those deep gullies that we see up there. And we hope, and we know, that our restoration work really slows down this erosion. So the first quiz question is, we compared the control site, which was left as bare peat, with a site that we restored. By what percentage was erosion reduced in the first 2 years? So as a result of restoration, how much was erosion reduced? Was it A, 67%, B, 88%, or C, 99% over 2 years? Stick your answers in on the right, and then we'll find out very shortly if you were right or not.
Well, everyone is answering that. Do you want to tell us how you measure erosion?
Yeah, sure. So we measure it in the streams using these devices. And it's essentially a 50 centimetre long plastic tube, and the water in the stream flows through it. And inside that tube are a whole series of polystyrene balls, which trap any bits of peat which are flowing through it. So we call that particulate organic carbon, so little lumps of peat suspended in the water, and they get trapped on those beads. And if we skip on to the next picture, we leave them out for a month, and then we take them back into the lab, and we clean out all of what's inside the tube, so the polystyrene beads and the peat which is stuck on them. So we then filter that, so we've just got the peat that's been trapped in a sieve, and then we dry that out in an oven and we weigh it, so we can weigh how much peat has been trapped. So if we do that process in the bare peat control site and also in the restoration site, we can then compare how much peat is being caught by each tube.
So why do we want our work to reduce erosion?
So from a climate change perspective, eroding peat emits carbon into the atmosphere on a fairly huge scale. You can see in this picture, this was actually at the one of the treatment sites before the treatment happened. You can see how much peat is washing down through there. So all of that peat is being lost from the moors, which is reducing the functionality of the bog itself, and also contributing to climate change through carbon emissions. And if we go on to the next picture, which is of the same weir several years later, you can see that there's vegetation all over that gully, and now there's no peat being washed down through that system at all, really. And that vegetation potentially is going to be taking carbon dioxide out of the atmosphere and locking it back into the peat. So in a long-term sense, we're looking at quite a significant carbon sink as opposed to a carbon source. The peat in the streams is also of interest to the utility companies who own the reservoirs and water treatment works further down the line. because that peat washes down into the rivers, into the reservoirs, and has to get cleaned out of the treatment works at quite significant cost. So this is from Bamford Treatment Works. So yeah, you can see it's a really large amount of peat that they've been having to take out with the water. So if we can cut the amount of peat that's washing down through the streams right down, it's going to save them a whole load of work as well.
Okay. And can you tell us the answer to the quiz?
I can. So if we skip on to the next slide, this is a snazzy graph from the Making Space for Water report, which is what this project was set up under. And you can see on the left-hand side, that's the unrestored site, and on the right are our restored sites. So over 2 years, the particulate organic carbon was reduced by 99%. So it's basically just switched off that source of erosion almost immediately, and that's just with the really young vegetation getting in there. So as that thickens out, it's only going to get better over time. So it's a really huge result, that.
Yeah, and only one person guessed 99%, so hopefully everyone's very pleasantly surprised by that.
Yeah.
And
I think we've got a link to the Making Space for Water report. Oh yeah, there you go. It's just popped up as if by magic. So if you want to find out more about that erosion study and other bits of hydrology and vegetation from the early years of the work on Kinder, check that out. It's a good read if you like reading that kind of thing, which I do.
Thanks, Tom. So the second aspect you're going to tell us about is biodiversity. So can you tell us what it is, and also you have another quiz on it?
Yeah. So biodiversity is the mix of species that we have. So we're looking predominantly at vegetation species, but also animals that live up on the moors as well. So this photo is from one of our experiment sites on Kinder, where we've planted sphagnum, and you can see it's got a nice mixture of different kinds of plants in there. So that's the sphagnum going down the middle of the picture. That's a stream channel which is completely full of sphagnum, and then we've got shrubs. So on the right we've got things like bilberry, and we've got heather in there, and there's a whole load of different grasses which are coming through it as well. So we've got a nice mix of different species which are growing, and that's going to allow different small insects and small mammals and birds to live there as well and use it as a resource and as a habitat. So quiz question 2, hope you're all warmed up now. In 2015 we planted sphagnum in the catchment in which this photo was taken, and we measured the size of that sphagnum in 2018, so how much ground it covered, and then we measured it again in 2020, which is when I took this photo actually. So how much roughly do you think the sphagnum had increased in size from 2018 to 2020? So it's a moss growing up on a hill. Was it A, 100%, so it doubled in size, B, 150%, or C, 200%, so tripled in size in 2 years? So stick your answers in and we'll come back to it.
Yeah, well, whilst everyone's guessing that, can you tell us how you measure biodiversity? Yeah,
so our main method, like I say, we're mainly looking at vegetation, and we use the quadrat method, which you can see here, a set of photos all taken from exactly the same spot. So each year we go up and we measure how much area is covered by each different plant species within that square. So it's a 2 by 2 meters square. We put it down in exactly the same spot each year. So each year we can measure the percentage cover of each species and see how it's changed. So you can see, roughly speaking, there's a progression in there from top left to top right to bottom left to bottom right. And over those, that's probably 4 years, I think, it's changed from completely bare peat to a bit of a mixture of grasses by the bottom right photo. And then following that, we're going to get the more natural moorland species coming into that quadrant and really thickening it out and making it, really dense with vegetation. We also do some surveys for other bits of wildlife, so that's through our community science project, where volunteers go out and record sightings of bumblebees and different insects and birds, and more than mammals as well. Yeah.
So can you put us out of our suspense and tell us what the answer to the second quiz question was?
I can. So over 2 years, from 2018 to 2020, the sphagnum in that area increased by 150%. So that is doubling and a half. And I was particularly pleased with that, because if people remember, 2018 was one of the biggest droughts that we've seen in recent times. It was a really significant drought event, and sphagnum is a very wet loving species, so we were worried that the sphagnum was going to really suffer in 2018, but it's shown its resilience. And so to go through 2018 and come out the other side having doubled and a half in 2 years is a good on sphagnum. Basically, it's tough as old boots.
A fabulous result. So why do we want our work to increase biodiversity?
Yeah, so we want our work to increase biodiversity so that it can support a wider range of wildlife up there, and because it provides various functions in terms of things that we want from our woodlands. So, sort of like we were talking about before, reducing the erosion, which helps with climate change, improves water quality, and just creates a better habitat all round, and potentially helps with flooding impacts, as we'll come on to in a bit. If we look at this graph, this shows the kind of progression that we're seeing following restoration. So along the bottom axis is growth seasons post-seeding. So we're starting at 0, which was the year that the restoration happened, or even sometimes the year before the restoration happened in year 0. And then up the other axis, we've got the percentage cover of each type of vegetation. So what we see in there is the bright green line, the lighter green line is the nurse crop grasses I was talking about. So those lawn grasses. And so they spike quite quickly and then go back down, and they create space for the dark green line, the blue line, and the purple line, which are the more natural moorland species, shrubs, grasses, and mosses. So they're really taking off following the establishment of the nurse crop grasses. And then the bright blue line at the bottom is the sphagnum, which we're really interested in, and you can see that's doing super well following the planting that we did in year 5 along that bottom axis.
Well done to everybody who got that quiz question right. So the third thing that you measure is the impact of the restoration work on flooding. So can you tell us what this means and also introduce your third and final quiz question?
Yeah. So flooding has obviously been in the news quite a bit in recent years. And it's an increasing problem that we're seeing huge floods on a sort of alarmingly frequent basis now. Really, it's not uncommon that we get devastating floods, which didn't used to happen as part of climate change. So we're looking to see how our restoration work can contribute to reducing the impact of those floods. And essentially what we want to do is to slow the flow of water from the hills into the rivers, to spread out the load on the river through a big storm event, so that the level in that river never gets quite as high. So essentially, the slower the flow across the surface of the hills and into the streams on the hills, the better in terms of reducing impacts of flooding further down the system. So our third and final quiz question is: the time between peak rainfall onto and peak flow leaving an area is called lag time. Due to restoration in 2011, water is taking longer to leave the mini catchment in our experiment. By 2018, what was the increase in lag time? Was it A, half an hour, B, 1 hour and 40 minutes, or C, 5 hours?
Well, whilst everyone is pondering that question, can you tell us a bit more about how you measure lag time and why it's increased and why it is important?
Yeah, sure. So, sorry, one sec. There we go. So lag time is probably the most technical thing we'll talk about in this webcast. And essentially, we measure hydrology on the moors to do with storm flow using rain gauges and V-notch weirs. So in a rain gauge, we measure how much rain is falling into that catchment, and we take a measurement every 10 minutes all year round for years on end. And we also measure how much water is flowing out of the catchment through the V-notch weir in the stream at the bottom of the catchment. We do that every 10 minutes all year round for years on end. So if you imagine that the heaviest rain in a storm fell at 1 o'clock in the afternoon, and then the highest amount of flow came out of the V-notch weir in the stream at 2 o'clock in the afternoon on the same day, we'd say we had a lag time of 1 hour. So it's taken 1 hour for the rainwater to move through the catchment and leave, and that's what we call lag time. So we collect data, like I was saying, all year round, and it means that we can look at storm events in a huge number of storm events over the years, and we can see how the catchments are changing in their behaviour as a result of the restoration work that we've done. So there's a huge amount of data processing that goes into that, a lot of which has been done with our colleagues at the University of Manchester. And if we look at the pictures that we've got on the screen, you can imagine that in the top left picture, which is a bare peat site, obviously, the water is going to flow over the surface pretty quickly. There's nothing to slow it down. It's going to get into that stream and it's going to fly down that stream really fast. There's nothing to slow it down at all, really, except for the meanders. The gully blocking that we were talking about earlier, you can see in the top right picture. So we've got some stone dams in there, and they act like a bit like speed bumps. So the water's coming down the stream. It's going to hit one of those. It's going to have to fill up that pool and then flow over the top down into the next one. So that's going to slow the water when it's in the stream. We also really want to slow the water down before it gets into the stream, so while it's going over the surface, and that's where the picture in the bottom left comes in, which is where we've got our little stream of sphagnum. Sphagnum is a very dense moss, so it can store a lot of water just in itself, and so it makes a really rough surface for the water to flow over. Which means that the water is going to flow much more slowly just over the surface, even before it gets into the streams, if we've got enough sphagnum up there. And then the bottom right is a combination of those things. So we've got nice dense vegetation, and believe it or not, in that picture in the sort of bottom left, there is an old stone dam. It's been completely colonized by vegetation, including sphagnum now. So it's a really rough surface in itself. So that's where we're starting to get those gullies starting to fill in with vegetation. So we've got dams in there breaking up the flow, and we've also got vegetation in that stream channel, again breaking up the flow and slowing it down, hopefully increasing those lag times.
Fascinating stuff. So can you give us the answer to the final quiz question then?
Yeah. So I was saying hopefully it is increasing lag times, and I'm glad to reveal to you that it is increasing lag times. By 2018, in the catchment where we had put in stone gully blocks, done revegetation and planted sphagnum, we had increased lag times by 1 hour 40 as compared to if we hadn't done any restoration work. So that is quite a huge achievement. I can't see the results of who voted for what, but the import, if anyone voted 5 hours and is disappointed that we've only got 1 hour 40, then you need to bear in mind that we're talking about really small areas here. It's 100 meters from top to bottom of these catchments. So delaying flow by 1 hour and 40 is a huge achievement. And it's a little and often approach. So we're doing this across, a large area of the South Pennines, not just on Kinder Scout. So if we can slow down that flow of water consistently by a small amount everywhere, then the cumulative effect of that hopefully will become very significant in terms of reducing impacts of flooding further down the system. And one thing that's particularly interesting about the result on that catchment where we got 1 hour 40 increase in lag time is that the catchment where we just did the revegetation work, but without putting in the gully blocks or the sphagnum, so far we've got about a half hour increase in lag time, which again is a massive result. We're really pleased with that in the time scale. It's 7 years so far. But it shows that we've basically got an extra hour and 10 minutes of lag time increase thanks to the sphagnum and the gully blocking. And we think a lot of that is coming from the sphagnum, in fact. So that thing that I was talking about of slowing the flow right down as it's going over the surface, because it has to go through this dense layer of sphagnum. So that's a really encouraging sign. And I should also say that this result, the 1 hour 40 result, is very much hot off the press. It's sort of just come out from some work that's been done at the University of Manchester looking at these storm events. And there's a link to an article that's just popped up, which is an article that we've written with the University of Manchester about these long-term trajectories of change as a result of our restoration work. So that article came out about a year ago, I think. And this new information about the impact of sphagnum on storm flow is so recent that it's not even in that article. So you're going to have to watch out for more updates in the future, which will include those data.
Okay, well, thank you very much, Tom. Thank you for spending half an hour and just telling people a bit about what it is you do when you're normally at work. So you quizzed the audience, and now it's their turn to quiz you. We've had a few questions come in, so I'll just read some out to you. And I should say, if we don't get round to answering your question, we're able to answer them afterwards online, so hopefully no one will be left disappointed. So we've had a question from Kristen, which is, how does livestock grazing impact your work?
So on Kinder Scout, where there is no livestock grazing, and that was a choice by the National Trust around the restoration work. So particularly where we have the newly establishing vegetation, that's quite vulnerable to overgrazing. So if we did have a large amount of sheep up there, then that would be a problem for them, which is why they've put the fence up to protect that fragile landscape. So it's not, grazing isn't an issue on our bit of the project. It may be in other contexts that sites can handle some amount of grazing, but especially when they're very new, that it's important to protect them.
Thanks very much. So Luke has asked, how can we get involved with volunteering to help?
Great, yeah. So we, in the early photos that we had in this presentation, you can see some volunteers coming out doing sphagnum planting, and we also do our vegetation surveys in the summer and the water table campaigns in the autumn with volunteers. So you can check out our website, www.mooresforthefuture.org.uk, for volunteering opportunities. I should say that at the moment, we're not taking on volunteers because of the current situation with coronavirus, but there are other ways that you can get involved as a volunteer. And yeah, the volunteer contribution to Moors for the Future is enormous, and we wouldn't be able to do what we do without volunteers. So it does make a big contribution to our work.
Yeah, thank you very much, Luke, for asking. We've had a question from Chris that says, I've noticed a fair few small rhododendrons on Kinder over the last couple of years. Is there a plan to remove them?
Yeah, so that's something that National Trust have been looking at a bit recently. So the rhododendron come in with the heather brash, we think. There's probably some amount just in the peat surface, in the seed bank. And it is a non-native species, so it ideally won't develop up there. So it's something we're keeping an eye on. And in the future, if it does turn out to become a significant problem, then I imagine there will be an effort to remove it. It's as with a few species like that. There's some rosebay willow herb up there as well. It's unclear yet whether those species will survive up there, especially long term. Some species may sort of survive for a short amount of time and then die out. So there's an element of monitoring it and keeping an eye on it, which is again where our vegetation surveys come in. But if it does develop into a significant problem, then for sure, it will be dealt with. Yeah.
Great. So Daisy has asked, how would you monitor a peatland restoration project if you had only one staff member and a small budget? What's the most important thing to monitor?
I guess it depends what the priorities are, because depending on the exact condition of the peatland and what you're trying to achieve, that's going to determine what you monitor. So if you're particularly interested in carbon, then probably erosion would be a key one to monitor, and that's fairly low cost and doesn't take so much time. Things like vegetation surveys are more time consuming, so you need more people resource for that. So I'd say erosion is a fairly good one, because you can do that, you can leave it, and then you can come back to it in the future. Things like monitoring the hydrology is quite labour intensive or time intensive, because it takes a lot of data processing and quite a lot of setup and maintenance of equipment. So I'd say probably erosion is a good one. I mean, some things also, like vegetation, you could do a survey right at the beginning, and then you could go back to that in 10 years time and compare it then. So, not everything has to be done in one burst, if you like. I'd say the most key thing is, regardless of the size and scope of your project, is to make sure you set it up well at the beginning, and really make sure that you are able to find out what you want to find out from the way that you set it up. So make sure that you have a control site is a really key one. It's been completely invaluable for us having a bare peat control site, which seems counterintuitive in terms of restoration. Why are we leaving this area of bare peat that we're not doing anything about? But it is like an absolutely priceless museum archive for us, and without it we wouldn't be able to say half the things that we can. So yeah, just really making sure you've got the fundamentals of your experimental setup really solid means that you can then come back to it in the future and be able to say a lot more.
Great, thanks. A question from Luke: is the current air quality still having a detrimental effect on the bogs?
So things like air quality have long and complex implications for the bogs. So atmospheric pollution, which the bulk of it was sort of during and post-industrial revolution, that those pollutants are still in the peat, and they are still having a significant impact on the functioning of the bog. And so, for example, there's a lot of nitrogen which has been deposited on the peatlands, and then sulfur dioxide, which kind of reduce the impact of that nitrogen. But that nitrogen, now that we've got less sulfur in the air from improving vehicle fuels, that nitrogen is now being released. So actually we're seeing an impact of that nitrogen only now, which interestingly is meaning that plants are growing faster because there's a big supply of nitrogen in the top surface of the peat. So the interactions are complicated, and for sure, air pollution that's being generated today is not good for the moors, and that will limit their recovery to some extent. But the interactions between different pollutants are quite complicated and take long periods of time to unravel.
Thank you very much. And then we've got our final question from Linda, which is, how big is the site? She says, sorry if I missed it, I didn't see the scale. Yeah,
sure. So Kinder Scout is a large plateau. It's around 30 kilometres to go all the way around the edge path. So that gives you an idea of the scale of the whole of the plateau. The sites that we work with, so we've got those 3 mini catchments, and they're all about 0.7 of a hectare. And in length, they're all about 100 metres long. So the 3 are as similar in size as we could feasibly make them, so that we can compare them really well with each other. So yeah, it's about 100 metres length from top to bottom. So they're really quite small. Yeah.
Thanks. Sorry, Tom. I said that was the last question, but I think we've got time for just another one, if that's okay.
Yeah, go for it.
So Tim has said, I was interested to hear that you spread lime to reduce the acidity before planting your nurse crop. Does that have any long-term effect on the vegetation, or is the soil pH stabilised after the nurse crop has given way to moorland species?
So yeah, you're exactly right. We have to put the lime down for those nurse crop species to survive, and we found if we don't do that, those initial grasses won't survive. And the reason that those nurse crop grasses, on that graph that I showed, that they sort of died out after about sort of 3 to 5 years, is because we stop applying lime. And as soon as we stop applying lime, those nurse crop grasses will die out. So the pH sort of goes back towards where it was. The pH drops again, becoming more acidic as soon as we stop applying that lime. So it will stabilise sort of fairly quickly, yeah. But without it, the initial phase of the restoration work simply doesn't work.
Thanks very much. If we haven't been able to get to your question as we're running out of time, we will pick your questions up online later. And you could also find more information out on all our work and everything Tom's talked about on our website. So thanks very much for tuning in. And thank you so much, Tom, for taking time out of your day to talk to us. It's been a pleasure speaking with you as always. And you can watch this again anytime you like on our virtual Bogtastic fan page on our website. For the next 2 weeks, the webcast will be taking place at an earlier time of 11 o'clock, still on Thursdays. The next 2 weeks will be a 2-part series, and it will feature 2 mini lessons on UK blanket bog habitats. It focuses on links to both the GCSE science and geography syllabus. So our Youth Engagement Officer, Jackie Ragg, will be exploring firstly the blanket bog ecosystem, and in the second of her webcast, she'll be exploring the blanket bog species and adaptations. So make sure you tune into that if you can. So we've got a short video, lasts about 2 minutes, of Tom's work on Kinder that he shot for us a little while ago. So do stick around to watch that if you can. And thank you very much, everyone, for joining us this afternoon.
See you later.
Bye.